Alright guys, in today's video we're going to be doing some work on this Ryobi benchtop bandsaw. This is a BS904G, I believe. Someone brought it to me asking me if I could salvage it. It's got a problem where it doesn't start. I'm going to kind of twist it around here to hopefully get the best sound into the microphone. But basically when you turn it on, all you're going to hear from this induction motor is a humming noise. Right, so that's the problem. It's just not starting up. Now originally the owner reached out to me with this problem, and I suggested what they might want to do is take a look at the side of the motor, and this little bulge here is a cover for a starting capacitor. And I suspected this might be the problem, and it's kind of a low cost item. I think this entire unit is probably just a little over a couple $100, so there's really not a whole lot of repair work you would tend to want to do on it. But I said you might want to try checking this. And they opened this up and they took this out. This is the capacitor that comes from this Ryobi motor from the factory in China. And we can see that it's a CBB60 type capacitor, 20 microfarad plus or minus 5%, 250 to 350 volts AC. So I said, just give this a test, and if it's bad, try replacing it. Now you end up having to cut this out, but I'll show you that we're going to they said this tested bad, but we're going to just show you testing it ourselves to be sure. Your multimeter, if it has, it's going to have some type of capacitance test on it. And we're just going to hook these leads up. This is not an electrolytic type capacitor, so it's not important where we put the leads. And we're just going to let it do a test. And what we can see from this test is we're reading 17.62 microfarads. It's 20 microfarads plus or minus 5%, so it means it has to sit between 19 and 21 microfarads or it's bad. So this is a bad capacitor, or at least it's out of specification. So it was a good call to replace the capacitor, but it's still not working. So we're going to go through here today on what else it might be. So the first thing I'm going to do is open up the motor here and see if the replacement capacitor is in fact good. Now I gave them a part number that would fit in this housing, and that's the hardest part on replacing these capacitors. When you take a look at the original one and we get out our digital caliper here, we can see the dimensions on the original one are about 34 millimeters in diameter, and then since it's a CBB60, 60 millimeters tall. And that is the original specification physically that fit in here. So let's take this guy off. Let's see, it's probably better to use one like this. So we've got one here that we'll need to take all the way off. There's a washer and a screw. And then the one up in the front here, if we can fit in here, and this is where I might have to use the skinnier one. We just need to loosen it. It's got a notch on the end. And we can see here's the one that I suggested they use. And it still says CBB60. Its dimensions are a little different, but it still fit. It's actually got a base diameter of around 31 millimeters. And then just slightly longer, it's just over 62 millimeters. So that still fits inside this metal cover just fine. So let's see if the new one was in fact good. See if it's something easy. So we just power tried this, so we may still have a charge in this capacitor, so we want to be a little careful with it. First thing I'm going to do is I'm going to put the voltmeter back on volts. And I'm going to go ahead and discharge this capacitor. Make sure it's not reading any voltage whatsoever. And then we're going to go ahead and do a capacitance test on the replacement capacitor. We can see the replacement capacitor is reading 20.4 microfarads, so this is a good capacitor. So this was a good call to replace. This one, the original one was out of spec, the new one is in spec, but that's not enough to get this motor going, so it's something else. Looking at all the sawdust around here, the next thing I'm probably going to suggest we try and do is just blow all this out. Now you might be thinking, well, why don't you just replace the motor? You already know you got good power coming to it. You know the capacitor's not it. Well, if we take a look at the service information from Ryobi for this guy, so it says a BS904G, right? And we take a look at the repair sheet. We can go in here and we can see a parts explosion for all the stuff that's involved in this model. Here's our motor right here, part number 20. You can find down here that the motor is a part number 089-120-406-702. What you'll find is this motor, probably the best price you'd be able to get on this is around $180. So that makes this not past the general rule of if the repair is more than half the replacement cost, you replace the entire unit. You don't bother trying to repair it. So what we're going to try and do is salvage this by not replacing this motor and see if we can get it rebuilt. I suspect the problem is that there's a switch inside here that is part of the start circuit, and it's got all this sawdust in here. It may be crudded up. This is not that old of a unit. If I show you on the other side here, we take a look at the specifications sheet, or sticker rather, on the actual motor. You see this induction motor was manufactured in April of 2021. And actually the first thing I suggested the owner is, there's a pretty generous warranty from Ryobi on these. It's 3 years. But they did not save their purchase receipt. And of course Ryobi is pretty stickler about having the original receipt or you don't get any warranty service. So unfortunately this is the route we're going to go. So let me go ahead and give that a shot. I'm going to go get the air compressor set up and we're going to see if we can blow this out, but first we're going to remove it. So let me show you that and then we'll show the second piece. So I'm going to kind of twist this guy around again. You can see there's a couple of socket screws in here that are Allen head. They are a 6mm size. And I found that they are typical Chinesium quality. You're going to have to kind of give them some persuasion to fit. And then a little cheater bar to kind of break the initial torque. And they're going to be on there tight. There it goes. This is the screw that's used to adjust the belt. We're going to do that first. Actually, before I go any further, I forgot to pull the plug on this. Let's de-energize this guy. Loosen this one up. And then we'll come in here and get the same thing down there. Sometimes you'll actually hear them give a little pop when they let go. So it's just a little socket screw. All right. Fortunately, this thing's small enough to maneuver around. Open up the bottom cover here. You see again, there's a lot of sawdust in here. Adjust this now to it's loose. Get the belt out of the way so that it doesn't get damaged. Take this guy off. Now she spins okay by hand, so that's a good sign that we're on the right track here. I don't see any damage. I do see a lot of lubricant, and I don't know if that's been put on by the factory or it has run out of a bearing or something, but that is unusual to see all this oil here, I think. Let's go ahead and get the capacitor hooked back up. And what we're going to do is we're going to try to restart it with no load on it. So we've got it disconnected from the unit. It doesn't have the blade pulley putting a load on it. Let's see if we can get it to do anything like this. Misplaced one of those little wiring covers. somehow. There it is. All right, we don't even have to put the cover on. We can just set it down here. I'm going to go ahead and plug it back in again. And we're going to see if it starts up with no load on it whatsoever. Nope. All right, the next thing I'm going to do, you don't want to do this when it's powered up. I'm going to give it a spin like this, and then I'm going to turn the power on. I'm going to see what the behavior is when I do that. So she tried to go. She's still not going. So what does that tell us? Well, what I'm trying to do there is to see if there's any binding when it's magnetically energized. I'm also trying to see, do we see any smoke? Do we smell anything burning? Everything looks fine. So again, I'm still thinking this is just debris covering up the switch that's preventing us from getting into the starting phase. At least that's my guess here. So let's move on to de-energizing it again, and let's go ahead and get some compressed air over here and see if we can bring it back to life. All right, guys, let's see if we can wake it up. Nope, nothing yet. So I think what might be the issue with us, with what we're trying to clean here, is the centrifugal switch that we're trying to access, I think, is actually blocked by this upper piece. And so in order to get into it, I'm going to have to go ahead and disassemble it. It looks like to disassemble it, looks like a little Allen bolt might be holding on this pulley gear. And it looks like there's 4 Phillips bolts here, probably holding the 2 halves of the housing together. So let's go ahead and do the next level of disassembly. This top one looks like it's going to be, let's go ahead and try like a 3. Might have to get a wrench or something to hold this steady. All right, so I'm going to go ahead and get something to hold this steady, and then just take a Phillips screwdriver and take the 4 on the back off. Try to not damage these teeth with these plastic covers on the jaws. Yeah, this is even tighter than the ones that were holding the motor on. Nobody ever bought these guys a torque wrench over at the factory, I guess. You can see there's like a considerable amount of flexing. I don't want to strip it, but if we can't get the gear head off, we won't be able to separate the motor. There it goes. I heard her pop. Yeah, that's on tight. There we go. Yep, now next thing we have to do is separate that. With that out of the way, I'm guessing we can just get a puller in here and pull this off. All right, so we'll come back to that. And we've got the power cable going in here. It'd be nice if we could get it disconnected from the rest of the unit. Take this off here. We've got it de-energized. Nothing's plugged in. So we'll see what sits behind the power switch, and maybe there's connectors we can get unhooked to get the motor separated from the main assembly so that we can work on it a little bit easier. Rather, right now it's tethered. All right, yeah, so it looks like everything's going to kind of plug in here. And what I'm guessing is that one of these lines is the one coming from the motor with a neutral, a hot, and a ground. So we'll have to figure out which one of these is this one down here. Take the strain relief off here. We should be able to pull this whole thing out so we can get the motor separated from this piece here. So let me take a little bit of a look at how we might get this off without breaking it, this little stress relief piece, and then we'll be able to give it some tension, or maybe we can just give it some tension with it is like that. Nope, we're going to have to get this off. So let me figure that out and we'll come back. Yeah, it looks like just depressing this guy might be all we have to do. Okay. So now we should be able to see on this side, right over here, which one of these moved, and it was this one. All right, so that means we're going to take this connector off of the power switch. Of course, everything on this unit, as you've seen, is like super tight, over torqued, and not very service friendly at all. And so these connectors are no different. They just don't want to let go. Probably the only thing we're going to be able to easily get off of here is the ground. Be careful of this little lock washer in the back. And take note of the order of all this stack, right? You got a lock washer, a flat washer, then the ground tab, then this star washer sits between the ground tab and ground, which is the unpainted area on the frame here. Make sure you get that back. So when we reassemble it, we want to keep it as safe as it was to begin with. All right, so that one came off pretty easy. So what's up with the hot wire? Well, there he goes. I don't know. He was giving us a pain before, but he's fine now. All right, so we'll be able to get this out. Fishing it back up here is going to be fun, but we can get it out. All right, so now we've got the motor separated out here. We're going to go ahead and take the capacitor off again. I'm going to go ahead and pull these 4 long screws off. Once again, we got something that's really, really tight. When I get something like that, what I'll do, you'll see me doing here is little quick jerks, almost like a manual kind of impact. And you're pushing down on it so that you don't strip it, just like that. And it's also good to make sure that the bit that you're using, these are not, GIS being a Chinese-made product. You want to make sure the bit you're using is correct for the size fastener so that you're getting maximum contact. less chance of stripping or ripping when you have things are over tightened like this. If this hadn't worked, I also have a Phillips head little impact kind of hammer tool where you put it in like this and you give it a hit and it gives a forced twist that can help break the torque on things like this. All right. Super long, kind of like what you'd find in an old school starter motor on a vehicle. All right, I see a seam here. This looks like it's welded. There's nothing holding the top anymore. We'll go ahead and take the other screw washer setup that was holding the cover for the capacitor off just because it's there. Let's see if we can tap anything loose just to see how it goes together. We still have to get this gear off. Just want to see if maybe the top of the frame is friction fit. It looks like it is. All right. So we can see this is a friction fit. So we'll be able to get this off. There's the bearing. So what we have to worry about now is getting off this gear on the top. So I think this is just a washer that was being secured by that screw. There's some type of adhesive in here. Yeah, looks like it's epoxied on. Great. I mean, this was not intended to be serviceable at all. But without the screw there, we could probably overcome this. Just get this sawdust stuff out of the way. You could probably overcome this with a gear puller. So what I'm going to do is I'm going to take a picture just to get a view for how far down the shaft is compared to the head here. Looks like there's, just a small space here. I want to say like a millimeter gap. And when we put it back together, we just want to take note of that so we'd have the belt and the pulley aligned the way they're supposed to be. And then we'll pull this off. What I'm going to do is use a 2-jaw puller. And I don't want the tip to damage the threads. So what I'm going to do is I'm going to stick a pretty thick washer that's at the right shaft diameter. And then another one on top of it, just going to stack those. Capture those inside the, kind of like the guide pilot. Make sure we're not on the gear and we're strictly on the shaft. And then we'll see if we can break the friction fit here. I'm going to have to cover your view to get a good grip on this puller. I can't tell if we're getting anywhere or not. Yeah, here we go. Yep, she's coming off. Just don't want to have the gear get stuck on the plunger here of the puller, which it may have already done. Let's see. Nope. Okay, good. Maybe just a little bit. right. That's out without any damage. That was the main thing. We wanted to make sure we didn't damage anything. All right, now take this frame piece off. Just going to use a rubber-ended mallet here. To get that off. And all that is there's a wavy washer sitting on top of this bearing. There's just a ton of dried up sawdust inside. So now I'm just trying to see how we can get the bottom off here. So we got another bearing in the bottom here. I don't know if this bottom piece comes off. All right, I'm just going to use the flathead side of this screwdriver and a rubber mallet. Just going to kind of give it a big whack. Let's see what actually we're going to do it on the seam here where we can get a little bit more in. Yep, good. Just needed some more persuasion. All right, so there's our armature and the rear bearing. All right, guys, I took an opportunity just to get everything cleaned up here, the rest of the sawdust off of these pieces, blow this stator assembly out, and make sure that a visual inspection that I don't see anything obvious in terms of burning on the windings or the little cloth that's used to hold them together on either side here. And so we're going to do some final electrical checks to try and see if this motor is salvageable. But the first check we're going to do, I probably should have did earlier, and I really don't suspect it, but just to show you how to do it and just eliminate it as a possibility, is a power check for the power coming in to the switch. So we want to have this switch in the off position, and we've already, of course, got the motor disconnected, but we're going to go ahead and re-energize this guy. Get our meter set up here. Set it to volts AC. And let's see what we get. So we got it in the off position. We don't expect to see anything. And we don't, just some transient noise on the line. Now if we turn it on, get this where it's nice and tight. Got about 126 volts AC. So we know that we were getting the right amount of power sent over to the motor. So just to eliminate that as a possibility, we would do a test like that. So now what can we do with the motor itself? Well, the whole reason we took this apart was we thought there might be some contacts or a centrifugal switch of some type that works in conjunction with the capacitor. But this is a much simpler type of motor. This is a motor where this capacitor is permanently always wired in series with one of the windings. So single phase permanent capacitor type induction motor. So for this, there's not much more we can check than the windings themselves. So the first thing I'm going to check with that is I'm going to set the meter in continuity mode. Test this out, make sure we're toning out okay. And what we're going to do is we're going to check the ground line. So we're going to see from the ground line here on the eyelet to the frame that we got connection. And we do, right? So we got connection to the frame, even wherever the paint is scratched, even down here along the frame of the stator. So we've got a good ground. Now what we also want to make sure is that we do not have continuity to either of these line ends. So either neutral or hot for the main winding, which is what these two are going to be, or for the secondary winding on these two lines from the capacitor. So nothing is grounded out. So that's good. So it means that we don't have a ground. The next thing we're going to see is, do we have an open in the wiring? So again, on continuity, we'll take the 2 inputs from the main. We want to hear tone, which means that we're going in through the winding, coming back, and we want to make sure that we don't have an open on the secondary. Now this is about all you can test without clipping these zip ties and starting to disconnect everything. Basically what we've got going here is the 2 lines that are coming in, go in here, they get spliced, part of them goes into the main winding, part of them goes over to the capacitor wiring, which then is in series with the second wiring, second winding. So something like this would look, I brought a piece of paper out here and a little pen to try and diagram this out. But I think basically the way this circuit is going to look is something like this. So we're going to basically have, our 2 lines here, and they're going to come over. This is going to be the main winding. So now talking about these 2 lines here, just ignore the ground for a moment. There's going to be that. And we've got the guy who's the rotor. And then we're going to have another winding where it's going to be 90 degrees off. Let's just call it like right up here. This is going to be our capacitor, right? And what we're going to end up having is these guys are going to be wired together at some point. So I don't know exactly how it's wired, because we don't have a wiring schematic, but we're going to have a secondary winding and a main winding or primary winding. The capacitor is going to be in series with this one, and then this guy is going to end up coming over here and connecting something like this. And so what we're going to want to do here with the test, we're going to want to take a resistance test. And I think what we're going to want to do here is between the main and hot and neutral, we'll be able to get a reading of resistance like this. But we'll also be able to do a resistance value by coming in and looking at, well, what do I get if I go through here? So the capacitor is out, right? So we're going to have a point where we can take 2 more tests here and here, which represent these 2 lines here, right? So we should get several different values. So I'm going to set this meter on to resistance mode. And we're going to start trying to check these out and see what we get. So what we're interested in seeing is, well, we know we don't have an open, and we know we don't have a short to ground. But do I have a short between the 2 windings? That's what we're going to test now. So I'm going to come over here, and I'm going to go from here to, I'm going to test these 2 points here, from here to these 2 points here. So the first one, what I'm getting is like a little over 2 ohms. And then if I try the other leg of it, so the other side of the capacitor, six and a half ohms. I'm going to do the same test from the hot line. About 5.5 ohms. And then from here, almost nothing. And so that makes sense, right? Because one of these tests is going to be just one of the windings. Another one of the tests is going to be getting the path that gets both of these windings in series. And one of these tests is just going to be the straight wire with neither of the windings. So far, we've done all this work. And I'll put a better diagram up here. I'll see if I can find a diagram online and kind of pop it up in the upper right-hand corner of the screen just to give you a better idea of what I'm talking about here. So at this point, we really don't see anything obviously wrong. I mean, the only other thing I might normally do is maybe cut this open and see if there's something in here, but I had no indication that there's anything shorted. The only thing you can really repair on one of these is this area up here. If you found something shorted up here, I got a chemical here that I would have used for that. It's called red insulating varnish. It's basically similar to the material you see already on the windings. We can fix something up here because we can move it around after we clip these zip ties. You can't repair the actual windings. And this type of motor is just not cost effective to rewind it. You know, the amount of labor would exceed the replacement value, and we already said the replacement value of replacing the motor exceeds the replacement value of the entire saw assembly. So at this point, all I can suggest doing is putting it back together, and that's what I'm going to go do now. So what we'll do for that is we've already cleaned all these pieces off. Here's our back plate, our front plate, our wave washer sitting in there. See a little bit more sawdust on that guy. All we're going to do is reassemble all this. Now I'm going to take a little light coating of 3-in-1 motor oil just to get along the shaft areas, mostly for corrosion reasons. These bearings look fine. They're spinning, you know, the way you would expect. And I'm going to go ahead and get in a position here where I can press this guy back on. There's a flat on one side of the shaft right there, and there's a flat on one side of this guy, and we should be able just to, you know, tap him back on again without having to drag him over to the press. This kind of metal is kind of soft, so like before we were trying to make sure we didn't damage or deform it. We got a very teeny tiny gouge on it from the puller, but that's all we did, and that's not going to hurt anything because it's going to sit right there on the flat side. And then whatever they use to glue it on, I'm going to put a Loctite product. I'll show you that when we get to that point. But I'm basically going to get it partially assembled, then we'll come back and I'll show you the final assembly. All right, let's get this guy reassembled here. Take a little bit of oil. Just going to go around the shaft area here. We're not going to go around the outer bearing because we want that to be a snug fit into the end frame. We're going to do the wavy washer too. This is mostly just for anti-corrosion purposes. All right. Then we're going to run this guy back in through here. This guy through here. We'll orient him around the way he was when we first took him off in terms of where the capacitor and this sat. Right now I just want to get it on part way so we can do this guy. So what I'm going to use on this, instead of whatever they used, is Loctite 680. Get this stuff to flow here in the cold. Doesn't take a lot. For all I know, this is what they used, right? Who really knows with the lack of specifications? All right. Now we ended up measuring that this was about 1.07 millimeters from the top. And I think it was going to be secured by the stop at the bottom anyway. Go over here and get our little Allen wrench. Throw our washer back on and get this guy tightened down. You may have to hold the shaft in order to get it going. I can see this washer is typical Chinesium quality. Doesn't even really clear the screw. There we go. Hopefully we didn't damage the threads getting this thing off. If we did, I might have to go get a tap and chase them. Let's see if we can get this in here. I got to block your view for a minute because I'm just trying to make sure she starts in without stripping anything, no cross-threading. All right, now I'll tighten it up later. What I want to do now is I'm going to have to go back and refer to the video, and we want to get the orientation of this frame the way it was. And we don't want to drag too much on these upper pieces because we'll end up cutting this insulation. So let me go figure out exactly how this was oriented. We'll get it tapped into place and we'll put these long bolts in there. All right, guys. Got this lined up on the flange here for the mount right with the seam. Got that flush, and now with that in position, we've been trying to keep the rear lined up with one of these bolts. What you want to do is, I don't know if you can get it in the camera, but you kind of look down here until you can see the hole all the way through. I don't know if I can get it. Yeah, right there. And now you know you're lined up for these guys. So we can drop this in. Yeah, that one started. We're just going to do the same thing to all of these. And you want to be careful with it, right? Because you don't want to get it going wrong and then cross-thread it. All right, so that one started. That one started. This is the last one. The other thing too is this this bolt will potentially nick or scrape the windings, right? So you want to be careful with it. For some reason we got all of these going good. I'm just going to go ahead and make sure they feel like they're still threading in. Yep. This guy is not cooperating. Now he is. Okay. Just had to kind of twist around and let gravity help us a little bit. All right, so I'm going to tighten these down, just kind of going on each side. I can feel the frame fitting into the housing. We're just going to keep going until we don't have any more slack, and then we'll give it a snugging up. This is another one where you just want to push in good so you don't strip the head of the Phillips bolt. All right. All right, so now we got this guy. I think we got him as tight as we could get him. I'm going to have to go get my pliers, and we'll grab the gear, and then we'll tighten this one down, this 3mm one down as far as we can. We'll go ahead and get the capacitor reattached, and let's just get this one down as tight as we can by hand. We don't have any spec or torque values or anything, but we just don't want to strip it. I believe it has seated. All right, we'll move on to the capacitor. Have half a mind to clip these leads and make them shorter, but we'll just leave it be for now. There's no moving parts inside, no switches, no contacts. There's nothing else we can clean. We've done about all that we can do here. We'll go ahead and just leave it out for a moment. We'll test it like this. I do want to kind of pivot this stuff around and get it grounded. And then we'll give it another test and we'll see what happens. All right. Everything's still spinning freely. Same deal. So guys, all I can conclude from all this is that even though we don't have an obvious short in our tests, those resistance values may not be correct for this motor, and there may be some subtle damage to the winding. So nothing that we could obviously see. So unfortunately on this one, I can't give you an actual repair here. All right, guys, so bad motor. So we're going to pull it off again. So like I said earlier, right, it's not worth buying a new one of these and attempting a repair. It's just not cost effective. And we presume this one's bad because of those resistance values. As it turns out, I did a quick search around eBay, Craigslist, Facebook Marketplace, and I found somebody selling one of these, and I was able to get them to show it to me working. So I know it's good, and it was at a price that makes it worth doing this repair. I'm going to show you how to put this back in, but I'm also then going to go take the resistance measurements on this working motor so we can see effectively for sure what actually happened on this other one. This one's a lot older. It was made in 2014, so 10 years old, but it works. At least I saw it work. Let's make sure it still works. This way you'll get an idea for what it's supposed to sound like and everything when it's working. So we'll connect this guy up real quick. We've done this so many times we're ready to go get a job on the Chinese assembly line doing this. Put our ground in just for safety. Of course, we just dropped our little ground washer, but that's okay for this test. I'll fish it out later. All right, plug it in. And then this should still work. And it does. Nice and quiet. No vibration. So we've got a working motor now. Let me fish out that lock washer from the ground pin that dropped down here, and then I'll show you how we can take a piece of wire rather, or I'm sorry, a piece of thread or cord or string, whatever you can get. Fishing line would work too. And the reason I was saying fishing is I'll put a fishing sinker on the end of this. Got to open it up a little bit for the string to fit. And the only thing we're doing here is this will allow us to plop this guy down into this hole here, right, like about that, so that we can see him over here and tie our leads to it and fish them back up the top here. So let me get that lock washer and then I'll show you that. We'll get this other replacement motor hooked up, get it back on the belt, and then we'll go ahead and cut the capacitor in here out. We'll do the measurements here. We'll put our replacement on, verify that was not the problem, although I'm pretty sure it isn't, but we'll check that. And then we'll measure the windings from here on each of the white and black wires to each of the wires on the capacitor, and we'll see what resistance values we get. All right, we fished out our little ground lock washer. We're going to take our sinker. I'm going to drop it down on the other side of this main line. Whoops. Get over here. I had it. There it is. All right. Now we're going to take our new motor. And we'll remove our sinker and put it back in our tackle box. And then we're just going to tie the string around these leads. Don't want to knot it up too bad, but just want it to stay where it'll not come off while you're pulling it back out. Got to work them in one at a time for the fitment. Okay, there we go. We got them all up here. Now, this replacement motor is missing the stress relief. I'm just now noticing that. So we'll need to take that off of the original one. And we'll put it on in the same spot. Pinch him back on there. As long as we get it in the same spot, it should be happy. There we go. Just squeeze it with the long nose pliers. You shouldn't have this much trouble with this if you got one on here already, but because it was missing for whatever reason on this donor, it's a little bit stiffer to get back on. All right, then we'll come up here and we'll unwind what we did here. And then we'll reconnect everything. Black to black, white to white, both facing outward, just the way we found it originally. We'll take our ground line, copper exposed area faces up. Start it by hand and snug it up with a Phillips screwdriver. Now we won't screw this back on yet because we're going to want to take our measurements. Now let's get the motor reinstalled. We got a couple of our bolts over here. We'll take our adjustable bolt first. Then we'll take the standalone bolt. Again, get it started by hand. This guy will snug all the way down because there's no adjustment on this lower one. Flip it back up. Take this belt here. We'll get it on the pulley at the end of the motor, and then we'll pull the motor all the way over to tighten it up. Hold it tight, we'll snug it up back here. We just want to see this belt is it's taut, but it has a little bit of flex to it. In that case, we're done with that. and then we'll tighten it up. And what we're going to do here is, so this motor worked freestanding. Will it work with the resistance of having the bandsaw wheels and the saw blade as resistance against the motor? That's the last test. We want to know that we got this repaired. And then we can go ahead and take those measurements, and that'll end the video so you'll have some reference. All right. Plug it back in again. And now we should have a functioning saw. Just don't touch the connections if you're doing it like this. All right. She's fine. So now I'm going to disconnect it again, and then we're going to start taking our resistance measurements. So let me go get my multimeter and we'll come back and do that. All right, let's get this capacitor cover off on our replacement used motor. It's tough to get at this inside one, but it only has to be loosened. Okay, so this is not even that great of a capacitor. It, as you saw, it came apart just giving a tug on it, and it's got a cracked case. So it's a good idea to open this up anyway. All right, so this is the factory original capacitor on here still, and I'm not touching anything here because I don't know if it's still holding a charge. So we're going to go ahead and clip it. Just trying to decide where best to clip it. I think for now I'm just going to cut it at the longest points. All right, so take that guy off. So the first test we're going to do is, was the problem our replacement generic capacitor? So we're going to see that first. Yes, I should probably go grab a pair of wire strippers, but this is just a quick test. So I don't really care if it's done right, this part here. Just need to make basic contact. So that's a very interesting scenario where we saw that capacitor was just falling apart in there. And yet it still worked. And we saw how when we first took a look at this, the original capacitor was out of spec. So, it doesn't have to be perfect to work. So I suspect, what we're doing here is unnecessary. But we're just going to do it for the sake of completeness. All right. She should probably operate on her side, but I don't want her to accidentally short out from vibration. So we will go ahead and put our wire covers on here, just in case. And again, guys, this is like super temporary, quick and dirty test here. We'll do this the right way after we finish this test. All right, so was this capacitor originally okay? Well, we're going to find out. I think this will operate sideways. Actually, I forgot that I disconnected this motor, so I'm going to have to stand it up anyway. Reconnect it. Plug it back in. Make sure our capacitor is still hooked up okay. Does she still work? All right, she works fine. So that was a good capacitor. So that wasn't the problem. So next, Going to de-energize this again. Going to disconnect it again. Going to disconnect the capacitor. And we're going to go repeat those resistance measurements that we did earlier. So last time, here's a better graphic than the drawing I did. So last time we measured from the white power lead coming from the motor to the red lead coming from the capacitor and the black lead. We had 2.4 ohms and 6.5. And then from the black mains to the red and black, we had 5.5 ohms and 0.4. I don't know if this is exactly how this motor is wired up, but it's very similar. So we know the one with the least resistance is going to be a run like this, which is just a bare wire over to this capacitor lead. So this is illustrative of black to black, black to black. If we take a look at the black to red route, the black to red route would have been something like this, where we go through the main winding and the secondary winding in order to get over to red. That gave us 5.5 ohms. The white running to red would have just ran through the main, just ran through the start winding, and then going to black, it would have ran through the main winding. And that's where we got the 2.4 and the 6.5. So what we're going to do is we're going to repeat these 4 measurements, and we're going to see what we get off a good motor. All right, so we're going to turn this guy around again. And this is the last thing I'm going to show you guys in this video. All right, so here's our white, here's our black coming from the motor. Disconnect the capacitor. And we'll end up putting that white one back in. And then here's going to be our white lead and our black lead. Let's just repeat these resistance measurements. Let's see what we get. All right, so last time we went from white to red, white, and I guess when we said red last time, let me take a look at the old motor. When we said red, we were really talking about white. If we look over here on the old motor, when we said red, this was white. All right, so we're going to go from white to white, white to white, white to white. We've got 3.3 ohms. And last time, we had 2.4. Actually, it's jumping up a little bit. Make sure that I am not inducing that by wiggling around here. Get this wire out of the way. All right, white to white. Much larger. Let's call it 13.2. 13.2 ohms. Let's call it 13.2 ohms. So instead of 2.4 this time, we got 13.2. Bad, good. Let's do white to black. So white from the motor, and then black down here. What do we get? Looks like it's going to stabilize out at around, let's call it 6.7 ohms. That's about the same. 6.5 to 6.7. Now we're going to go from the black motor lead, and we're going to do the white lead coming off of the windings. Let's call it 19.6. Yeah, we'll call it 19.6 ohms. Far more. And then lastly, we're going to go from the black on the motor to the black on the winding. Call it 0.4 ohms. 0.4 ohms. All right. So I had made some notation here just to show this, but I'll cross this off, right? So These are the same, so nothing's wrong with this path, this black to black path. White to black is about the same. So there's nothing wrong with this path. But the path white to red and black to red, we've got more than half of the resistance is gone. We should have somewhere in the range of 13.2 on this leg and 19.6 on this leg. So it is in fact a bad motor with an internal winding short. And so the resistance changes because of the location of the short in the windings. It's not an open, it's not a short to ground, it's a short between the windings internally. So good call, bad motor, nothing we can do to repair it. And what we've done here for the owner on finding a suitable used one is about the most economical repair we could offer. I'll go ahead and wire in this replacement capacitor, which does fit the case on this particular type of motor. So you can keep the case on. I'll put a link to it in the description. I hope all this helps you guys out. It's a lot of detail, but there's really no information on these particular single-phase induction motors with in-series capacitors, and I thought this would be helpful to spend some time on this. I actually was not expecting to be able to fix this. It was a very lucky break to find one of these for sale used. I would say what you want to look for on the price on something like this, you can go buy a brand new one of these Ryobi saws for about $200 to $230. You don't want to spend more than $50, $55 on the motor. If you can't find it, then best to just part it out or scrap it. In this case, though, we found an economical repair. If you got questions or comments, leave them below. I'll try to help answer any questions you got. If this video helped you, you found some useful information in here, or you just found it interesting, I'd really appreciate you hitting that like button to help pay it forward for the time it takes to put these kind of videos together. And as always, thanks you for watching.